So again, good morning, everyone, and welcome back, and good evening for those of you who are in India. The topic for today would be prompts. We'll cover what it is, why it matters, and I would like to preface it by saying this topic, prompts, is likely to evolve. It's still in a very early stage of development. It is likely to evolve, and it is likely to a large extent replace traditional programming or become an adjunct to it. So what will happen is we are going to enter a world in which we are using a mix of prompts and your favorite programming language to accelerate your software development process. There are a lot of magical things the prompts seem to be doing. Those of you who have been keeping track of it are probably aware that we have reached a situation at which, for example, there was just the other day, I noticed on Twitter, I'll remember the project, one person showed a video in which, with proper prompting, an agent, an AI agent, could not only write code, it could actually create the entire deployment pipeline. And while it was at it, go ahead with it. Just from descriptions of the project. So the prompts are also the foundation for this emerging world of AI agents. AI agents is a topic that we'll cover in a subsequent week in this bootcamp. I'll get you guys started on it, though it is a rather rich and deep topic for which there is a dedicated course, which I invite you to attend later. What are prompts? How did they come about? Nobody seemed to have heard about them 3-4 years ago. And yet, it seems to be everywhere. It sort of came into vogue with the coming of ChatGPT. What was known in the research community and the technical community about large language models, about transformers, namely that if you give it certain input, then it can produce certain output. Then, with some interesting development, namely the fact that you could, there's a whole process called instruct tuning, that made these large language models not just produce a relevant output, but make it appear as though it's answering your question. The tokens that it is generating seem to be answering your question. When that came about and ChatGPT got released into the popular into the open world, which was, I believe, November of 2022, it caught people's imagination. It's transformers from being things, language models from being things relevant to researchers and to engineers, professionals, which would have been like 10, 20,000 of them. All of a sudden, it caught the imagination of hundreds of millions of people. In fact, ChatGPT adoption curve was one of the most phenomenal adoption curve. I think in a matter of weeks or something like that, there were already millions of users or tens of millions of users. Right? Today, I don't know what the latest statistic is, but I believe that the number of users of ChatGPT is somewhere between 100 million to 1 billion. Anybody happens to know the exact stats? But it's a phenomenal number. In 2 years, you have done that. Just to put it in contrast, things like Facebook or Twitter or anything else, TikTok, they took time to get adopted, even though subsequently they would become part of the global human consciousness, right? All the social media. But this thing caught on. So the questions to ask is, from a popular perspective, what is prompt? And then from a technical perspective, how did it all come about? What made it possible? Why is it that we couldn't do it before? Ultimately, transformers were discovered or created, rather invented in December of 2017. What took 5 years for it to reach a stage at which it became something that everybody finds essential these days, whosoever has encountered with it? And so in that sense, we will go and read some of the foundation research papers, but we'll take a gradual approach of peeling the onion today. Now, prompt is a big topic. Once again, just about everything that I'm teaching you for reference is a big topic. Last week we did RAG. As many of you know, I gave you enough RAG, what is called baseline RAG, right? Enough to get you started and to realize its importance. Throughout this course, I'll open doors to new worlds, but each of these worlds are vast territories. If you want to learn more deeply about those territories, of course, pick what interests you. You can't, of course, learn everything all at once. Pick what interests you, and then you can go register either here at Support Vectors or wherever you want to the more advanced courses in those. So today we are simply opening the door to the world of prompts, but hopefully I'll give you enough depth that you'll feel quite conversant with it. So in its simplest form, a prompt is an input to a large language model. And let me situate myself here. In a large language model, as I said, what is a large language model? If you remember, a large language model is made up of an encoder. Basically, if you do an encoder decoder, though these days it is mostly the encoder only. So I'll just leave it as a box, a part of the transformer, right? I'll just say language model. What you do is you give it a text, the cow, over the, and you ask it to continue the sentence. And it might say, oh, sorry.
Like last time, you change the background.
Oh, to black. Okay, I will change the background. Sorry, I should have remembered doing that. Let me do that. Page color. Draw is fine. Insert. View. Page color. No, page color. So the what? The cow jumped over, and what you expect the machine to say is the moon in, let's say, in sheer, something like this. I'm just cooking it up. So what is this? This is an example of a continuation. We know how this machine works. We have studied the transformer. We have studied the decoder. We understand the causal model. Are we clear, guys? So this is where we are. Now, there came an interesting breakthrough, which we'll come to subsequently, which is the Instruct GPT paper. Because of that work and other, obviously it's not one paper doesn't do everything, but it was the culmination of a lot of research that was taking place. What happened is you could ask questions like this, write or explain to me let's take something completely abstruse, to me, the something, let's say from, you could feed it this, and you could say in no less than the Fermat's last theorem in no less than 1,000 tokens. And what the machine would produce is a wonderful, wonderful explanatory essay, isn't it? And you could go further in a level that, at a level that a fifth grader can understand. Now, think about it this way. Yes, yes. Think about it this way. When you do something like this, there is a difference between predicting just the next word here, which seems to be relatively easier. You can, if you were to work it out in your imagination, what is happening is you feed it this language representation. You have the vocabulary from the word aardvark all the way to the word, let's say, I'm just writing the vocabulary, and then somewhere is the word moon, and you expect that the probability of the moon exceeds the probability of all other words, isn't it? And if that were true, well, in reality, you sample. So this is your this is your softmax layer, which is your last layer. When you sample off the softmax layer, now the thing is sampling off. Means it could have picked this word, or it could have picked another relatively likely word, right? For example, it could have been the probability of fence. That also could have been reasonable. Jumped over the fence. Are we making sense? And the sampling part is that it may, with a certain probability distribution, pick either this or that and so forth. It doesn't necessarily pick the most likely word. To pick the most likely word is just one sampling strategy, the greedy strategy. It could use other ways. You understand that. And after that, after this word moon is committed, now moon is here. Maybe this word has high probability, right? And this and this. So up to a certain distance, it looks fairly explainable. But to see a machine take an input like this and then be able to produce a really nice long essay that would have taken us a day to write is quite remarkable. How that has become possible, again, is a whole body of research, but in that, sort of the culmination was with the paper. That is, the Instruct GPT will do that. But for now, we'll peel the onion a little bit slowly, and we will say that that which goes into the language model is the prompt. That which comes out is, of course, the answer to the prompt, response to the prompt. Are we together? And when you think of it like that, you can almost think of it as input going into a box, and you have an output, a response. For those of you who come, for example, from control systems, mechanical engineering, electrical engineering background, do you see a resonance with control systems and control theory? So recently, people have argued that there's a very deep connection between prompting and control systems theory. Okay? We won't go there, but I'm just giving you a flavor of the response. So given an input, one of the first things people observed is this. This machine samples off. So let's start writing some key observations that people began to come out with. Key observations. Number one was the machine samples off the softmax. What does that mean? If you sampling is a non-deterministic process, isn't it? What does sampling mean? So for example, if I take, where is my jar of stones? Here it is. See, if I were to take this jar of stones and I say, give me a sample stone, and you close your eyes and you dip into it and you take a stone out, then you put it back. And then the next time I say, give me a stone, you pick up another stone. Are you likely to get the same stone over and over again? You're not. So sampling inherently is stochastic. It's non-deterministic. Are we together? The nature of sampling is it's non-deterministic. And so you realize that unlike control systems, there's something very odd going on here. We created the machine samples from the therefore, and this is the first and most important realization. The LM language model is inherently non-deterministic. Now, this non-determinism was a cause of great concern. People said, what kind of a machine it is? I ask it a question, next time I get a different answer. But that was deliberate. Let's say that you say, tell me a story. You would hate it if to everybody it told exactly the same story over and over again. Isn't it? The injection of non-determinism or sampling off the softmax was deliberate. See, the easiest thing is you don't sample off the softmax. Those of you who are familiar with classifiers, what do? If you have a softmax, if you're telling whether a picture is a cow, a duck, or a horse, you have a softmax with 3 nodes. You have a probability for cow, duck, and a horse. Whichever is the greatest, the classifier will say, that is what it is. It's a duck. Are we together? Those are deterministic machines. But a large language model, they deliberately injected non-determinism. Why would they do that? Anyone would like to guess? Why would they want to inject non-determinism into a machine? That seems pretty destructive, right? You ask it a question, the second time it won't give you the right answer. So I sort of answered it. One is that there are many situations where you don't want repeatability. You want it to be creative. So tell me a story should produce entirely different stories every time. Tell me a story about a cat should not produce the same story. Does that make sense? Right. Not only that, they found that if the more you control, the more you move towards determinism, the blander the answer becomes, the more inane the answer becomes. Right. See, if something is most likely or obvious, human beings don't need to use a fancy machine. They know it. Isn't it? When you go to a large language model, you expect to learn something that you didn't know. And the most probable answers are usually things that sometimes you know. Does that make sense? So it was a deliberate act to move towards non-determinism. But non-determinism, is a very expensive sacrifice to make. Because what it means now is sometimes I do want the answer to change, but sometimes I don't want the answer to change. So here's a situation where you don't want the answer to change. In the early days of the LLMs, people gave, or with ChatGPT, if you remember, you would give it an essay and say, give me a critique of the essay, right? And people were amazed. It would write a very detailed and very sensible critique of your essay. You would ask it to rate it on a scale of 1 to 5, and it would say, I would, on the whole, rate it as 4. And here are the positives about it, and here are the negatives. Turn around and ask it to review the same essay again. And the machine would say, what a terrible essay, right? This is wrong and that is wrong, and it barely deserves a 1 out of 5, right? A 2 out of 5 or something like that. So you realize that there is a problem. What happened? Why did the machine change its opinion so drastically, right? And the answer to that, there are many answers to that. It's a very complicated question. It has to do with technical things like the temperature and the hallucinatory effects and many, many things. But to a large extent, the problem also is the prompt with which the text was given did not clearly articulate how should the machine review, what measures, what is the benchmark, what is the yardstick by which the machine should measure your essay. You're asking it to measure on a scale of 1 to 5. But you have not been sufficiently clear in articulating the definition of a good essay and a bad essay. What makes it good? Right? And how would you go about judging it? So then people began to realize that this input is, you have to be pretty good with the input. You have to be rather smart with inputs, smart with prompts. So developed a cottage industry. You will find, if you go to Amazon, for example, that there's a whole large collection of books that have emerged on prompting. Suffice is to say that each of the book competes with the other in being the most useless. And I'm not saying it maliciously. I'm saying it because there were early entrants. They were pretty much in a hurry to express what they found quickly. People are saying, oh, I found this. It was all written with good intent. And if you do this, this is the kind of results you get. Except that those results were not very reproducible. Right? With a small change of parameters, those techniques wouldn't work. Then came more thinking about what really is going on. And 2 years later, 1.5 years later, we have a better understanding of how these machines think internally, LLMs, what's happening. I wouldn't say that we understand it, but let's just say we have a better inkling and more powerful understanding of how to prompt the LLMs has emerged. So you will see, and now very recently, some new textbooks have started emerging on prompts and prompt techniques, which I think are much better, right? But there is one good resource which is sort of written by engineers. Actually, most of the resources on prompting were written by gardeners who, but they didn't look like engineers. They were people, they were hackers. They're people like sort of with good intent. They all went excited with LLMs. They tried this, they tried that, and whatever they found seemed to work with all good intentions. They went about sharing it and writing books, right? And lots of books exist. But after that, when a hard look was given by researchers to think through this whole topic of prompting and asking this question, how should we prompt the machine to elicit good responses? Then the subject started going far, far deeper. And I would like to sort of take you to one of them, which I would consider to be your main work for today. Prompting is a big topic, but we'll cover some of these techniques. It is, and it is called Prompt Engineering Guide. Though today we distinguish between prompt engineering and programmatic prompting. There are two different halves of this. In other words, we have now very systematic ways of optimizing prompts, things like TextGrad and DSPY. We'll come to that later. In fact, today itself we'll come to that. But I would say that if you are looking for a trusted source to get started, this is it. On the course portal, I have surfaced a few more. Actually, I think I will surface because that section is hidden. I'll unhide it. So, or maybe I have unhidden it. One of you can verify whether, let me verify that. Let me go into a student role. Oh no, this is a wrong course. LLM-1 Bootcamp, okay. Switch role to student. Yes, I have to reveal the whole prompt. Oh, promptly done. Well, basics of prompting is here, but I have a lot more to talk about in due course of time. So we'll start with that. I have revealed something. So what happened is people began to think about prompting very, very seriously. And lots of research papers began to come out. For example, zero-shot prompting. What does it mean? I'll explain to you. Few-shot prompting, chain of thought prompting, and meta-prompting, self-consistency. I will, in the course of today, give you a flavor of each of these things. Notice that RAG that we just taught you is also within the umbrella, sort of stretching it, but within the umbrella of prompting. You're basically saying, I'm going to write a prompt, but augment it with search results. So therefore, it is a prompting technique, right? So today, I will systematically go through some of these prompting techniques. But your entire work for this week, guys, is if you are in the space of LLMs, as you are, prompting is not something you can take lightly, because the realization is that if you become good with prompting, then it pretty much takes over many, many professional responsibilities. Anything that is of intellectual origin that needs knowledge and reasoning, except for deep reasoning like theoretical physics or something, to our great misfortune, it still doesn't unify relativity and quantum mechanics, but maybe someday. Um, but generally, very deep reasoning aside, commonplace reasoning that we do in the workplace, whether it's medical, whether it's programming, whether it's accounting, etc., it seems to be doing an excellent job. So LLM is like that. It's this unwieldy tool. If you don't know how to use it, you won't actually harness its power. But it has superpowers. And the way to access the superpowers is through prompting. Right? Now, this is a very general, so it all feels like a pep talk. So, and I deliberately wanted it to be. Let me end this small, very general pep talk kind of a thing with one statement. At the end of the day, you will realize that prompting is to a large extent going to take over programming if it has not already. I'll give you an example. Andrej Karpathy, who used to head Tesla's self-driving car lab, then worked at OpenAI, GPTs, and so forth, he made a famous statement. That statement is, I believe this guide might say it somewhere. Okay, the famous statement which became the talk 2 years ago, or 1.5 years ago, he said, English is the hottest programming language. Right? It sort of woke people up, and it really is so. It took a while for that statement to fully reveal itself, the truth behind it. But today, and everybody says, for example, Karpathy, who has written all of these things, llama.cpp and whatnot, right? Some of the deepest code. He says that more than 90% of his code is written by AI. Like, these are people who are very proud of writing deep, careful code. Yet they say that when you sit in front of a computer and as you start typing, you just have to put your thoughts there, and the AI, the large language model, writes the code for you. What is it? What is putting your thoughts there mean? You're prompting it, isn't it? There are endless plugins to OpenAI, and through Llama, through this, through that. You can just enter your Visual Studio Code. Many of them free, many of them paid for. The latest craze is for something called Cursor. I've used it. Amazing. If nothing else, use the Copilot, GitHub Copilot. And when you write your code, just start by writing the comments. What is it that you want this function to do? Right? Then write the signature of the function. Sometimes it won't even give you a chance to do that. The moment you write the comment, it has figured it out. And lo and behold, it has written out the entire function for you very, very often. And I have seen this. I've really seen this. It has written it in a way better than most programmers would write, more carefully. In my case, one of the things it has done is I tend to code very stringently. It's a defensive coding habit that I picked up from my shorts project, a project that I did when I was young for NASA. As you know, for NASA, it's very simple. You can't launch $1 billion satellite, and just when it is about to land, let's say on Mars, you say, oops, there was a null pointer exception. Right? So as they say, failure is not an option. So one of the best programming practices I have seen in my career is with NASA. They're very, very careful with their code. So I write in a particular way. Many of you who have read my code know this. And I noticed that these machines, they have picked up on my coding style. They have read through all my code. So when they suggest a code, they don't just suggest a generic code because they know that I used to cancel it out. And now the code that it suggests, literally, I could have sworn I wrote it. Right? Quite often. But it doesn't. See, it works about 70, 80% of the time. 30% of the time, I still have to go and edit the code. and make changes to it. But even as I make changes, it figures it out. One example that you can give is you can take your code and give it to the LLM and say, critique this code. Literally, critique this code. And you will be pleasantly surprised how in-depth code review it provides for you. So when you give it a code and you say critique it, what did you just do? When you just highlight a section of code and then you hit on your Visual Studio Code or cursor, whatever it is, and ask it to critique it, what did you do? You prompted. Do you realize that? You prompted, and what you got back is better code quite often, right? So that is the power of prompting. That is really the power of prompting. But how do we become that good? Yeah. Like tennis, prompting doesn't come by just saying, hey, it's just English. Anybody can write English. I can assure you that engineers can put a spaceship on the moon or on Mars. They can do pretty clever things. But the one thing they absolutely cannot do is, guess what? Express clearly with clarity, right? And good language is something pretty alien to engineers. I'm sorry that I'm saying it like that, but it's definitely true. Ask a ask us like I used to be a C, C++, Java coder. Ask one of them to create a web page. They'll say, "Oh, of course, no problem. It's just HTML. I'll pick it up in 5 minutes." Well, 1 hour later, they'll come back. The page will be all black. The title will be big, bold, right? And it will be a masterpiece of ugliness, right? The text will barely make sense. It will have no context, right? It is because engineers were so horrendously, absolutely terrible that entire departments were created called user experience, right? Which is populated by people with interdisciplinary experience. It's a reality. So I'll give you, again, at the conclusion of this pep talk, I'll tell you a story. This really happened. One day, right here in this class, a person was in deep anger and frustration. That person had been looking for a job, right? Had a job, was making somewhere in the order of 150 to 200K, something like that, everything put together, and was a deep systems programmer. And this person is attending this class and suddenly says, Asif, do you know, I just saw an advertisement on Anthropic. I say, yeah, what is it? It's for a prompt engineer. And guess what? The base salary is $350, 350K, or I don't know, base salary or total comp. I forget the details, 350K. How is that possible? How is that possible? Why should somebody be paid just to write English? What do you think is the answer to that? Why should somebody be paid twice what you're paid after 20 years experience for writing English? Yeah, well, of course, there are many, many answers. One simple answer is nobody pays you for how talented you are. People pay you for the business value you bring. It's economics, right? It's basic economics. It's also demand and supply. But the most important thing is prompting is not as easy as you think. So I looked at him, I remember, with a straight face, and I said, "Oh, yeah, is the revenge, uh, is the revenge of the English majors." For the longest time, they have been sitting on the fences and saying, what is this guy? These geeks are being paid so much. So now it's our turn. Well, the reality is what you think of as just English is not that easy. For example, when Shakespeare writes his sonnets, it's not just English. Certainly, you as an engineer couldn't have written it. Right? And if you set your benchmark that good poetry, a prompts need as much effort, as much thought, as much careful preparation and articulation as good poetry takes, I assure you, you will become good at it. Think it through. Are we together? That has to be your approach. Yeah. Mhm. Mhm. The creative side. That's true. Well, I'm a left-hander, so in my case, right brain, I'm always thinking from the right side. No, I'm kidding. Yeah. I'm the only guy in this room who is in his right mind. All right. So kidding apart, right? So that is about prompting, guys. So let's take baby steps with prompting. The first rule of prompting is, see, these chatbots, right? Like ChatGPT or Anthropic, Cloud or Gemini, they actually do you a disservice. What do they do? Let's look at the user. See, sometimes user interfaces, right? They condition us to think a certain way or act a certain way. As you know, one of the great works of this architect, Christopher Alexander, was environmental architecture. Namely, he studied how architecture influences human behavior, right? And in the same way, I feel that the design of a UI, and this is well known, by the way, it's not something I feel, everybody knows that. The way a UI is designed shapes you into behaving a certain way. So let's go to Chat GPT and let's go here. I'm here. In this entire big wide screen, where do I enter? What do I have to enter? Way down at the bottom. And what does it seem to imply? It looks like a search box. It almost implies that enter a few words, isn't it? So it basically invites you, and even the examples are a plan a relaxing day, summarize a long text. What is the length of this prompt? Just a few tokens, right? It sort of encourages you or shapes you into that. Now, the first thing that I'll teach you is never, ever, ever write one-line prompts. Ever do that. That shouldn't be, unless you really need something as quickly, like what is today? Like suppose I say, what date is today? So then, well, I got the date. It suffices, right? Though you might have argued what a date is today in it took it a while. You realize that the second query was expensive, isn't it? This is why it would rather that you gave short things and you got quick answers from it. But the one rule is you don't do that. So I'll tell you, the first thing that we are going to learn is a proper template for prompting. There are many templates, good templates for prompting. The template that I will introduce you to is called the CoStar template. I have adapted it. So in other words, it's not strictly that template, but it is an adaptation of it. What does this template do? What this template does is, and how did it come about? See, when ChatGPT came, people were all puzzled. How do you get the right answer or good answers from the LLM? So there were lots of competitions. And the Singapore government, and Singapore, by the way, if you have not realized, is one of the most countries which is most aggressively focused on education. The quality of education there is just superlative, which is why a tiny, tiny, tiny country, which you can barely spot on the map, has an extraordinarily high amount of research papers per capita coming out and a huge, huge research output, especially in the STEM fields. They went, and as Singapore does, they take everything in a planned way. So you can quite imagine a bunch of very, very serious Singapore government officials sitting, hey, we need to figure out the right way to prompt. And so they had a committee come up. And the committee thought and tried and did something. And finally, they came up with the CoStar. And one reason I like about it is that when so many people have worked for so many months to create a template, they are not kidding. Right? So there are many templates. You can use your own template. I like this one. There is an article that you'll find on your website, on your course portal, that is, yeah. So this section, by the way, on your course portal is called Promptly Done. And we start today with a simple introduction, which is the CoStar framework for prompting. It's a Medium article. right? So you see 4 links here. Do you see 4 links, guys? The CoStar framework. The same thing I've uploaded because it's behind a paywall for you. If you want, I've uploaded it as a PDF. Ah, yeah, here as a PDF. So if you have your Medium, which most of you have, go and read it there. Otherwise, you can read this. The PDF is sort of loses some of its formatting quite a bit, but I will take you through this CoStar framework. Huh? The second is the prompting guide. Prompting guide is something we just saw, guys. Did we see the prompting guide? It is this, right? And the third link, the first two are the same. The third link is something I'll show you as a real life example. Right? And I'll show it to you as an example. Actually, how about this? Let me do this. We are used to the example is this. You notice that you can give it some data, a file. I want you to do this. Go get the old faithful geyser data. So before I explain the prompting framework, do this. Go to github.com, support vectors. And if you go there, search for when you go there as an outsider, you will search for a project called ML100. Actually, here. In this ML100, let me see. Do you see this old faithful geyser? Take this file, take this CSV. I'll explain what this is a picture of. Old Faithful Geyser is a data set about a Yellowstone National Park in US. There's the Yellowstone National Park, an amazing, amazing place where it is geologically unstable, geothermally unstable. The crust is not, is like, there's a lot of fissures in it, and heat from the mantle, from deep inside the earth keeps escaping. And there is this geyser which erupts every few minutes. And how long it erupts for depends upon how long you had to wait before it erupted. Right? So the longer the time interval between 2 eruptions, the more it will erupt for. Geologically or geophysically, that's obvious, because if the geyser hasn't erupted for quite some time, it means that a lot of pressure, a lot of steam has built up. Right? And so when it finally erupts, there'll be a lot of energy, a lot of hot water to exude. And so it will fire up for longer. That is this data. It's very simple. It's a 2-column data. You see eruption time, like eruptions, and waiting time. Eruptions is how long did it erupt for, and how long you had to wait since the previous eruption till this eruption. This is a 2 thing. I want you to do this exercise. Go to ChatGPT, upload this file, and basically say, give me a full, just do a analysis of this data. See what does it come up with. Just ask it to analyze this data. That is a simple prompt, right? At this moment, don't use anything sophisticated. I want to show you the difference between naive prompting and sophisticated and doing it well. Just take this data, put it in should I download and put it in one of the other courses? Yeah. But I will put this in the Discord. Let's put it on Discord. Any of my teaching staff, if you're still here, would you mind? Okay, maybe I'll do this right now.
Asif, I can help if you want.
Oh, thank you, Madhu. No. This one I just copied now. I just want to put it in the LLM-1. Should I put it in general discussions, guys? Right. General discussions. Let me do that.
I would put it in semantic search because there's a lot of activity going on there.
Okay. Semantic search, or isn't there a more into this? Edit category, remove. Okay, edit here. Okay, for now I'll put it in semantic search. So guys, look into this Old Faithful Geyser data set. Download this data, give it to ChatGPT, ask it to analyze and see what happens. And I'll give you guys 10 minutes and then I'll ask you what you observe. Seems fair, guys? Right? And once we have done that, I'm going to stop the recording. Unfortunately, there's no way to pause it, and we'll start another recording later.